Dobry daň. Dobry daň. Now it's better. Thank you. Good afternoon. As introduced, my name is Wojtek. I live in Poland, where I work for AWS, Amazon Web Services, as a developer advocate. And maybe this role doesn't mean anything to you, but to cut it short, the role of developer advocates is actually to listen to your voice as the community. So if there are any AWS customers, AWS community builders, any builders that will build on top of AWS, don't be shy. Approach me after the talk. I would happily listen and talk with you over the cup of coffee. And we would like to listen because we want to represent your voice inside the organization. That's our role. If you prefer online, you see my tags on the slide, on the Twitter and on the LinkedIn. Feel free to reach me out there as well. Outside of being developer advocate, I'm also a builder myself, a software engineer, cloud architect. I work in those roles to this day. And let's do a show of hands. How many of you work on software delivery on a daily basis? Raise your hand. I expect all hands in the air. Oh, most of them, at least. And we deal with software architecture on a daily basis as builders. I would like to introduce you to the box. Audience, this is the box. Box, this is the audience. Even though it's not a literal black box, it's a bit shy. It hides some complexities inside, and you already feel that there will be dragons there. If you see some details, you probably notice 2 availability zones, maybe some orangish boxes available there. But to preserve the desperation, fear, and anger when we ask what's in the box, we actually refer to the more or less defined structure, which is called the software architecture. As industry, we developed over the years a language of patterns which we are using as mental models to talk about the architecture and to communicate it. And we use it as a visual language and visual representation with lines and boxes. It's perfectly normal to represent them as diagrams to communicate to our team members and peers what those systems are working and how they are working. Still, we focus mostly on the boxes because that's where the complexity lies. But at the same time, lines are as important as boxes, and I will try to tell today the story why. Initially, you feel the difference between lines and boxes for sure. You know that boxes are representing functional characteristics, lines more or less non-functional ones, like availability, scalability, interaction modes, coupling, those kind of stuff. If I will show you 2 different systems with 4 identical components, A, B, C, and D, you instinctively feel that even not knowing anything about A, B, C, and D, you know that those systems are completely different because they are connected differently. And those connections are actually imposing how the system will behave, and we instinctively know this. We also know that lines and boxes affect the features and the capabilities of the systems. How we remember those capabilities? By learning patterns. And we are actually learning them and grow our personal toolbox when we deal with those stuff. And it's like growing a personal software toolbox over the years. And going beyond that, we are actually cataloging those things. One of the examples is this great book. Have you read this book? Raise your hand if you know this book, read this book. Enterprise Integration Patterns. Okay, nobody read it. Actually, I saw the hand out there. Great book. I can definitely recommend to the rest of you. Enterprise in the title can be discouraging, but the truth is it's all about integration, as we will talk today in the talk. And speaking about the integration and the lines, again, lines are defining the essential traits of our systems that we are building, and the interconnectivity between those components is actually meaning and having very important consequences how those systems work. Speaking about the patterns and mental models, if I will tell you that in our project we are using RPC calls, REST APIs, shared databases, you visualize how those systems look like in a physical way, how those systems interact between each other, because you know instinctively how those mental models are operating. If those diagrams look familiar, they are taken from the book I mentioned. And all those patterns have high-level representation of the system behavior, and also they are telling us a bit about non-functional characteristics. If you can talk about the integration and actually that it affects how application operates and how it influences functional and non-functional requirements, let's talk how we can use it with our advantage when we are designing modern cloud applications. First things first, we need to define what the modern software architect does. First is he's like a chef. He or she is like a chef. They are working with ingredients, selecting them, actually vetting if those particular ingredients are valuable for us, and then we can work on the combination of those, composing them into something bigger and better. Another part is how those modern software architects are focuses on the impact and how they span between the organizational representation and how they can impact the organization in that way. So the more levels they can span, the more they will deliver the impact in the organization. That was hard. Last but not least, they are selling options and not silver bullets, not something that will be a snake oil, something that will solve all the world's problems. Basically, they're saying everything about the honest research, about how you can leverage those elements independently, and they are telling everything about pros and cons. Nowadays, if you are working with the microservice architecture, serverless, those require adaptation to the software architecture side. And in this role, you are required to work with smaller pieces that are loosely joined together. And in that way, they are bringing much more value as a synergy. It's all about the synergy of the integration in those systems. And again, in the modern cloud applications, integration, those lines that I mentioned, isn't an afterthought. Those are things that are actually integral part of the application architecture and software delivery life cycles. That's the second quote from the book that I referred at the beginning. So keep that in mind because we will have more of those. So knowing about the patterns in the context of the integration synergy, let's talk about how we actually can leverage the patterns when we are building something more valuable. I will use the example from the book again. This is a loan broker. What is a loan broker? It's an intermediary between the customer requesting a loan, a credit bureau that sets some guidelines and expectations how the process will be regulated, and then multiple banks that are bidding for that particular request. The most important part for this particular application is how we are distributing the bids between the recipients and those who are actually requesting the loans. And this example is not chosen randomly because in the book there is a pattern described as scatter-gather. Maybe you heard about it, but it's more or less something like a multiplexer between multiple parties. So it allows you to orchestrating messaging flow that requires broadcasting a message and then gathering the responses back. Basically, you have someone who is requesting this thing and someone who is actually answering the request in a bidding way. But is pattern enough to create application? I think if you are not working a first day in the software engineering, you know that you need to do some design decisions that are much more nitty-gritty details than just the high-level pattern. For example, if the pattern visualizes the higher-level concepts, how we select the set of the recipients? Does pattern say anything about this? Not really. Are those recipients required to respond? And what are the requirements when it comes to this response? When to complete the aggregation, and is this a timeout? Is there an order of those received responses? And last but not least, what do we do with those responses in the end? Do we aggregate them? Do we sum them? Do we select the first one? All those elements are actually technical details, implementation details, that are not constructed, not incorporated into the pattern itself. And depending on those decisions, we can implement pattern in a very different ways. For example, if we will refer to the AWS in this case, when there is the availability to use certain services, there is a AWS step functions that allows you to implement the state machine, basically orchestrate multiple parties, multiple services together, and deliver the required scatter-gather pattern. On this slide, you see the way of orchestrating everything and then mapping the responses in the end and deliver the response in a proper way. Another way to implement scatter-gather is actually to have the event bridge used, which is essentially an event bus in the AWS nomenclature. And having an event bus means that we have someone who publishes an event and someone who receives the event. We can have the targets, we can have the rules that will filter those events, transform them if necessary, and we will have everything that is related to event service and event buses nomenclature as well. Last but not least, we can implement scatter-gather pattern in the regular publish-subscribe fashion. Basically, someone publishes the message and then subscribers receive those at the other end. On AWS, we can use simple notification service as an implementation of this particular pattern. No matter what you will choose, all those presented implementations have different traits: coupling, visibility, integration modes, performance, and so on and so on. Those are trade-offs I have mentioned, those options that we are selling as architects. And to emphasize here, knowing what particular service is doing enhances our high-level pattern with, and this mental model that we have, with technical implementation details. So knowing that we have to deliver a high-level pattern, and then we know that we will implement this with the particular service that is provided by the vendor, we can actually combine those two worlds and get more understanding and more meaning into the whole system overview. And this is just one example. In the book, you have multiple patterns available, the whole language, and all those patterns can be implemented in exactly the same way as I described to you. To sum up, integration patterns and our pattern language expresses how we would like to do our solution. And then at the same time, knowing the essential properties of the used services, we can actually combine the intent with the technical detail implementation that will be representing some nitty-gritty details that are not initially represented inside the pattern. And speaking about patterns, lines and boxes, and everything else, how to combine that to the actual real-world scenario on the resources that are deployed in the cloud. We need to talk a bit about the infrastructure as actual code. And to do it, I would like to introduce you first to the automation cycle. And some of you already know this, but it has 4 steps. First one is basically we provision the resources and prepare them to be used later on. We created those resources in the cloud. They are ready, available for us to use later. Then we deploy the application to those resources, prepare it to receive the traffic, but it's not there yet because those components are isolated. They are not grounded together. In the next step, we are composing them together, wiring, and we are actually making that flow that will connect all those elements together and make the application as a whole. And last but not least, we configure everything, tweak the right size, and prepare everything to receive the traffic, including our application code with some additional details related to configuration. This 4-step automation cycle is actually done very frequently with different languages. When we start with a desired state, we describe this as a desired state that will be written as an automation script. But we usually start from the actual state, and then we describe what we would like to do. And then with the help of the languages and the runtimes that are implementing this, either implemented as a document-oriented languages or functional or object-oriented languages, in a declarative way, we can actually define how those systems are built and automated. And this whole introduction about the automation and infrastructure as code, and probably most of you know about this, is important because I would like to show you a tool that helps you to design the whole thing with the expressiveness of the real programming language. So you can preserve the declarativeness of the whole approach, and at the same time has the expressiveness to think about business model constructs and business domain constructs available on top of your code. And this tool is called AWS CDK, which stands for Cloud Development Kit. It allows you to create your infrastructure as actual code when it comes to the development of the infrastructure definitions. It starts with the constructs, very low-level ones, resources available in the cloud, like the functions, individual functions, services, containers, queues, and so on and so on. Then you can move this a bit higher, and from those building blocks, create your own integration patterns expressed with the code. And last but not least, you can do those high-level constructs, business domain constructs, implemented in your language, in your ubiquitous language from your domain. I know this sounds a little bit interesting, so I would like to show you the demo in order to present the whole thing. So I will start with showing you how we can develop the loan broker in two ways. At this slide, you can see the two different CloudFormation stacks, which represents the exact resources created in the cloud. We have two different ways to represent our loan broker, either as a state machine or as a publish-subscribe mechanism. Here you can see the infrastructure code which represents both elements. First things first, you see that this is TypeScript. You can write this in Python, Java, .NET, and Go as well. But in this TypeScript language, you are defining all the resources that will be deployed in the cloud on a very high level. And at the same time, you can go and configure them, and by composing them and providing configuration regarding how those resources should be interconnected together. Now you can see the definition of the state machine in this particular case. And here there is a Fluent Builder, an API provided by the CDK that allows you to actually communicate and connect everything together as a result. So with this Fluent Builder, you are actually representing the flow of your code inside the infrastructure as code definition, which will be connected with your application domain and relevant terms that you are using in your business domains as well. As a comparison, you can do the same things with the publish-subscribe mechanism. So you are not using a state machine, but you will use an SNS topic. But eventually, you will deploy those things to the cloud. And in those CloudFormation stacks that will represent resources, you can actually see the relevant constructs from the Cloud Development Kit available as a tree here. And then you will be able to dive deeper into those elements and see what exactly is represented inside your core infrastructure code and what resources are created. So we are trying to, on the first level, bridge the resources mapping to the related elements that are more related with your business domain instead. And having this developed, you can actually show the additional relationships between your resources. You can do this twofold, either by AWS CloudFormation Designer that will be shown in a moment, or by the external tools. We will return to that later. So regarding the visualization that you can see currently, inside our CDK code, we had the constructs that were developed in TypeScript, and then those constructs actually created some resources in the cloud. Thanks to this view, we can actually map code, infrastructure as code, to the exact resources. And if we have the proper naming convention and proper elements defined in our stacks, in our definitions, then we will be able to deliver and transfer the meaning from the infrastructure as code to the resources that are deployed in the cloud. So assuming that you will actually keep your code clean and clear since the beginning, you will be able to obtain the composition and the representation on the application side as well. So skipping ahead a bit, I said about visualization of the resources available in those stacks. First things first, you can actually show them as the CloudFormation Designer, which is a very easy way to present all the resources in a visual way, how they are created in this particular stack. But this is a pretty complex way for the bigger stacks, and it can be overwhelming, as you will see in a moment, a bigger stack which has a lot of elements layout together, which is not a very clear way to define this. As an alternative, you can use external tools that are developed by the open source community, like, for example, CDK Dia, stands for CDK diagrams, which actually generates the real-world diagrams from your CDK code, so infrastructure as code, and then you will be able to see infrastructure mapping in a much more pleasant and visualized way, easier to actually manage and maintain. And skipping ahead a bit, you can see this exactly here. So this is a generated diagrams, infrastructure diagrams for two different stacks. This one represents a state function. So this is basically a state machine that will orchestrate a few elements. And then we have the publish subscribe mechanism with use of the event bus, so Amazon Event Bridge. And both are generated from your infrastructure as code definitions, and you can actually visualize on the first layer your implementation here. But here is the details and elements that are relevant for the infrastructure, for the resources, cloud resources. If we would like to visualize how the flow of our application looks like, then we will need to use different tools. And then we have, for example, state functions visualization. So here you can see the state machine that was created for this particular loan broker, which I explained at the beginning. On the left-hand side, you see a generated JSON definition of that state machine, which was generated from those builders that I shown you at the beginning of the demo. So basically, we were able to map from a very nice API to a deployed definition in JSON and visualize that on the console. And here is another way to visualize this in much more cleaner way, when you can see different resources involved in that particular state machine. And you can already see that we are using Lambdas for this particular services, and some of the steps in the middle are actually calling database and fetch the data from DynamoDB. In this particular case, we are fetching the list of recipients that will be notified about this particular loan request. And if you would like to visualize the same thing when it comes to the publish subscribe mechanism, you can do it exactly the same way when you will visualize the notification through the publish subscribe mechanism and also additional services that I reused for this implementation. So in both cases, you are able to see not only the infrastructure relationship, as we shown with the CDK diagrams or the CloudFormation Designer, but also how the code is composed and how the flow of the application looks like on the higher level. To sum up this part about the AWS CDK, we actually have different ways and different levels to implement our infrastructure as code definitions. We can represent infrastructure responsible for the domain concept, like in our case, a bank integration. We can create those functions which will be referring to the lower level constructs available in the library, and that will be actually creating actual resources in the cloud. And last but not least, if we will refer to everything that we created as an API for our functions and for our code, we can have different elements covered, starting from deployment, configuration, and then composition of different elements together. And in this particular case, automation isn't an afterthought, because if done right, it will impact your architecture and it will blur the lines between building and deploying your software. I would like to leave you with two key points, one inspirational one and one that is much more pragmatic. I will start with the pragmatic one. I hope that I convinced you that knowing patterns is not enough to actually build an application, but having those patterns combined with your understanding what your cloud vendor, for example, provides, and bridging those elements together with a way to automate your infrastructure can actually create a modern cloud application bliss when you are developing those things. And combining those three elements allows you for a pragmatic software development when the work that you don't have to do it is actually pushed on the shoulders of service providers instead of yours. At the same time, patterns will express still your intent. You will be able to map the business concepts into the proper domain language inside your code, and you will be allowed to understand those systems better on the implementation side. And if the previous point was pragmatic, I will allow myself to one last time refer to the author of the book, who recently in his essay said that basically cloud democratized creation. And I would like to, and this is one of the most interesting things if you will think about it, because if you compare your position to 15 years ago, it would be hard to stop listing places when everything affected your options available. And you might even say that if you will use the cloud, only the sky is the limit, but it may sound cliche and I will stop here. Before I will finish, here are the more important resources for you. I would definitely recommend the Serverless Land, which is the community-driven place that focuses on developing the great content about modern application design, modern cloud application design. And of course, the book I've mentioned at the beginning, Enterprise Integration Patterns. And I would like to leave you with those two messages. Thank you for your attention. No matter the feedback, scan the QR code and provide the feedback to me. You will receive a small token of appreciation at the end and access to the slides and also the code I used during the presentation. Thank you very much, and I think we have 3 minutes for questions.
Okay, we have an app for questions, but since we're running out of time, I'm going to use my mic.
Thank you. Thank you for the presentation. I have one question. So this looks great if you have like one part or one product that is working for themselves. But when you have enterprise and multiple products have this kind of architecture, and they are all kind of working together to produce some functionality that spans across. So how do you handle then the architecture and documentation?
That's a very good question. Thank you. So one of it's definitely implementable in their enterprise as well. The whole challenge is actually to set up the cutoff points properly. For example, if you will use Event Bridge as a cutoff point, you can share this event bridges, event buses between different accounts, between different corporations, even between different departments, and then everything is on the actually schema design and how you will implement those event messages in this particular case. So it's definitely implementable, but the whole challenge is to select properly the cutoff point, because otherwise you will have either no man's land in the middle or we will have overlap, which is also bad.
Good, good. We got one question through the app from Igor Antolic. Can we convert CloudFormation script to this CDK?
The answer is yes, we can, but it won't be ideal, because it would be impossible to actually make all the definitions and all the elements that are needed in CDK to express everything. We don't have them in the template initially, but it would be possible to do it because there is a way to convert CloudFormation template to the CDK definition, to the very raw definition, and then iterate with this code and improve it and make it more meaningful. So it is possible, but it won't be ideal. It will require more work.
Good. Thank you. We got time for one more question, maybe. If somebody has a question. No, everybody understood everything. Great, great presentation. Thank you so much.